I'm going to show how to use an interactive simulation for a system that has an azeotrope, and we're going to look at both pressure, mole fraction, and temperature mole fraction diagrams. Here is the link for the simulation, and then here is a snapshot. So we can select PXY, and you can see there's a maximum pressure. The azeotrope is where the mole fraction of the liquid and the vapor equal. You'll notice that at lower mole fractions, the vapor phase is enriched in benzene, but at higher mole fractions, the liquid phase is enriched in benzene. We can change the temperature, which will change the saturation pressures and therefore change these bubble point and dew point curves. On the right is a bar graph that shows the relative amounts. If we have a total of 1 mole, relative amounts of liquid and vapor, and their mole fractions. And so let's look at the simulation. So I'm looking at the pressure mole fraction diagram, and if I lower the temperature, then I lower the saturation pressures, these two endpoints, and of course change the entire curve since the curves are related to saturation pressures. I can move this black point around. Right now we're in the vapor phase at low pressures, high pressure in the liquid phase, and here we're in between, and we show these mole fractions. If I move just directly left or right, I change the relative amounts of the liquid and vapor. If I move over here, then we have now the liquid phase is enriched in benzene. Since we have a maximum pressure azeotrope, then we have a minimum temperature azeotrope. Otherwise, this is very similar. We can change the pressure, which changes the saturation temperatures. The simulation has details that have the Antoine equation and the equations for the activity coefficients and the modified Raoult's law that's used to generate the curves. And so the point is to better understand the properties of azeotrope. It's where we have a minimum or a maximum, in this case a minimum, in the TXY diagram, and where the mole fraction of liquids and the vapor are equal to each other.